And by the way, if you don't get enough math from me, I did post the link to the series. We saw the first one. It's a good watch. I'm not going to cry if you don't watch it. I understand. You're like, dude, this is more math than I want right now already. Don't make me on my own time watch math. But I think it was really well done. So hopefully some of you guys will watch it. So this problem here, let's do this problem together. I purposefully made this one kind of gross. More gross than it had to be. All right. So what are the steps involved in completing the square? Yeah, make room here. And why do I have to complete the square? If I say you can't use quadratic formula, can you factor this? Hell no. There's no factors of 5 to add to be -3. So get the 5 out of the way. Make some room, because you're going to put a better number here. That's the whole idea. You're going to put a better number here that will make this factor like that. And why the hell do we want to do that? Because then it's easy. I can just take the square root of both sides and be done with it. What sucks about this problem is the x squared. That really is what sucks. So if I can just collect everything together inside of a square, I can kill the square directly, which is what everybody wants to do in the first place. So what the hell am I going to put there? What's the steps involved for this completing the square? What do I do? Yeah, take the middle dude, cut it down in half. Right now, what do I know I can use that number for? Yeah, it's going to be the inside of how it will factor. And now I got to figure out what number has to go here. What number do I have to add, of course, to both sides? Yeah, take whatever you get and square. So that's the number that has to go here. And of course, if I put it on that side, I better freaking put it on that side and make everything legal. All right, let me stop there. Now, the worst part about this, because there were fractions, is right now, but the LCD between these two is easy enough, yeah. So you'll multiply this by 4. -20 plus 9. And now that we've learned section 10.7, you're not allowed to just say no solution anymore. Because what's my next step? Yeah, square root both sides. Oh, I'll pour a little blue dude. So then that cancels. You get x minus 3 halves equals plus or minus, what's the square root of 4? 2. What's the square root of -11? You could do one thing. Now be careful, don't say 11i, right? Yes, I squared 11. The square root of -1 is now I. Square root of 11 is I don't freaking know. I like it. And then one step away from the real answer, you just have to add 3 halves. And if you put it 3 plus or minus I rad 11 all over 2, it would have the same form as what you would get from the quadratic formula, 11. Because all quadratic formula does is it does this, it just kind of did it ahead of time. It's already done. You just got to plug the stuff in the right place. Maybe. See, so I made this middle term uglier than it had to be. It's not even, so you know you're going to have fractions. But even then, there's only one place that's going to be, you should be able to handle LCD. That's the one place where it gets a little freaky. All right, and we're trying to get used to this I idea, so hopefully that's cool, right? Does anybody have trouble with that square root of -11? I mean, that's the square root of -1 times the square root of 11, so it's I rad 11. Okay. How are we doing there? Is that all right? So here, you guys do this one. All right, let's see. What's the first step here? Yeah, make some room. Get that thing out of the way. Stupid 2. Loitering. And then what are the 2 steps to figure out what has to go here to make this work for the next step? Yeah, so the first step, cut that sucker in half, the middle term. It just, it's easy to forget why that's true, but you got to go back to that time we did the motivation, and we just noticed the pattern. Things like this, when you multiply them back out, we saw that that whatever's in here is going to be half of what's this, because you add them together to get the middle term, right? So, you got to go back and remember what that pattern was that we observed. So I know that's going to be how it factors. And then I just take this and square it. That's what's got to go here. I change that side, so I better change this side by the same amount. That's the step that's really easy to forget.
The only part that I can understand, how do we know if it will be x plus 9 over 2 or x minus?
Well, what's half of 9? 9 halves. The one we had earlier was x squared minus 3x, right? So we did half of negative 3 is negative 3 halves, so it would be minus 3 halves. So that question is answered already. It's going to be positive, yeah. Cool, I like it. Because half of 9 plus half of 9 is a whole positive 9. Cool. So on this side, you're going to multiply it by 4. So 81 minus 8. 73 fourths. And then square root. I like it. Start to get the cadence of the problem. So you get x plus 9 halves because these die. And then here this will be plus or minus square root of 73 over 2. Sweet. So whenever you can do a square root, you do it. And then subtract that and you're done. All right, now let's see if I can use this kind of ugly looking thing to do the next steps. What did we just find if I look at this as a function? If I'm given this, what is it that we just found about the graph of that function? So what kind of points specifically? There are very interesting points. X-intercepts. So these are the X-intercepts for this function up there. How do you find the X-intercepts? You make y 0. Well, what's y here? F of x. So if I make that 0, I find the X-intercepts. Quadratic formula always finds the X-intercepts for the associated function. Does that make sense? Because it's built off of ax squared plus bx plus c equals 0. It's always going to give you the X-intercepts. So what if they come out to be complex? The X-intercepts are complex. What does that mean is going to be true about your graph? Think about it now. Think about it. If you get anything that's real, that's where it hits the x-axis. If we only get complex, it doesn't hit the x-axis. It starts above it and opens up, or it starts below it and opens down. It just never hits the x-axis. So that's where the freaky video came in and said, oh, there's a whole other dimension. All right, let's not worry about that right now. For how we graph things, it's just not going to hit the x-axis because there's no real numbers where it does that if you get complex. This one is going to have real intercepts. Does it open up or down? How do you know that? I like it because it's positive here. Right there, that's positive. So that's going to open up. I like it. What's the y-intercept? What's the y-intercept for that function? Yeah, exactly. How do you find the y-intercept? You make x 0, right? I like it, I like it. If you had 18 letters in your thing, how do you find the W-intercept? You make all the other letters 0. It's just true. So here to find the Y-intercept, 0, 0, I get 0, 2. And somebody help me out. My X-intercepts, let's approximate them, because I'm going to be insane. I'm going to try to graph this thing. What are my X-intercepts? Somebody help me out here. So what's one of the X-intercepts? Negative 9 halves plus the square root of 73 over 2. Can somebody please help me out? My hand, I haven't implanted the cybernetic calculator yet. This thing that shoots out instead of the gun, the calculator shoots out. Maybe not. Maybe that's too dorky. Oh well. I'd say it's negative 0.2. Is it? All right. Sweet. All right. So that's about negative 0.2. All right. We're going to graph this by hand. So that's plenty enough decimal places. You with me? What about the other ones? Negative 9 halves minus the square root of 73 over 2. Negative 9.2.
Negative 8.7.
Damn, I went the wrong way. Negative 8.7. Oh, yeah. Ugh. All right. I like it. So the X-intercepts are negative 0.20 and negative 8.70. I'm desperately trying to get you guys to just get past your fears of numbers that aren't pretty. Who gives a shit? They're still numbers. You still plot them the same way. I'm not going to be able to plot negative 0.2 like exactly, but who cares? By hand, we just assume it's going to have some problems. We just want to get a rough estimate of what it looks like. Let me see. Go away. Okay. So now if I want to graph this thing, I've got all kinds of information. What's the one most important point we haven't done yet? The vertex. I love it. So how do I find the vertex? What's the shortcut? Yeah, it's actually staring into the face, but what's the shortcut itself? To find the x piece of the vertex, you do negative b over 2a. I love it. You have to know that? Yeah. If you want to get those questions right on the test, you probably want to know that. If you're okay with not, then you don't have to. What's b? 9. So it'll be negative 9 over twice 1. And we already knew it was negative 9 halves. See that? I don't know if you guys remember. Where does that shortcut come from? The middle of the answers that you get from the quadratic formula. There are intercepts. Where's the vertex got to be? Right in the middle. And that's the number that would be right in the middle of these two. I like it. So what's the vertex? Negative 9 half, comma, what? How do I find out what?
Put negative 9 halves into the equation.
Exactly. I know x is negative 9 halves. If I want to know what y is, I got to plug it in. So f of negative 9 halves. This is another place where people just sort of give up. Makes me sad, but you just plug it in. Negative 9 halves squared plus 9 times negative 9 halves plus 2. You get 81 fourths plus 81 halves minus. So the 81 fourths minus 162 fourths. Negative 81 fourths plus 2. Do this a little quickly, but I mean, did an LCD, so it'll be 8 fourths. That's negative 73 fourths. And then that's, whatever the hell it is. 18 and I think it's negative 18.25. Cool. So that's the vertex then would be negative 9 halves, negative 18 and a quarter. All right. Will you always have numbers as ugly? No. will the process you follow to find everything I just did be different? No, it'll be the same process, right? Let me just pause here. Everything we've done, a lot of it's old. You just forget about it. X and Y intercepts, you always find them the same way. Always, always, always. You find them the exact same way. Right now, the new thing is the vertex, right? And of course, if it opens up or down, anything related to the idea of the parabola graph is the new stuff, right? So now I can plot. Let's see if we can estimate this. My X-intercepts are -0.2 and -8.7, so I need a lot more of this. There we go. Jeff, you're not going to like that, are you? No, Jeff. So let's say 1, 2, 3, 4, 5, 6, 7, 8. So -0.2 is like right there. And -8, 1, 2, 3, 4, 6, 7, 8. 8.7 is like right there. Cool. And then you've got -4.5, right? 1, 2, 3, 4.5. -4.5, and then I got to go down 18.25. So let's do this. 3, 6, 9, 12, 15, 18. You can do it, John. There you go. Got to count just in the middle of the count. So 1, 2, 3, 4.5. -18.25 is about right there.
Where is the 4.5?
9 divided by 2.
Oh.
Yeah. It's funny. I wrote everything in decimal except for that for some reason. All right. And it's got to be in between these two, right? So you can kind of visualize and make sense, especially use graph paper. If you are anything close to me, you use graph paper. Oh my God, right? Please, dear God. Okay. Give me some idea of scale, so forth. And now I just got to connect. What's the y-intercept? Where'd it go? 0, 2, right? So here's 3 using the same scale, right? So 0, 2 is about right there, and it makes sense. It looks like it's going to wee. Oh, Jeff, you almost did it. Oh, you're not going to be able to live that down. There you go, Jeff. And then, wee-haw. Now, yesterday we didn't find the X-intercepts yesterday. We found a third point a different way, which was to do the mirror image of this over here. Right? But if you find the X-intercepts, you don't need it then. You've already got plenty of points to fill in that parabola. I like it. Okay, so that's there's a lot going on in this problem. And you're all like, yeah, we can see that. Let me see, what else did we do yesterday? This is the one I want to do next. I think that pretty much captures most of what we did yesterday. So we're going to do a little bit of new stuff, and then I've got a little handout, of course, that captures basically everything we've done in Chapter 11 so far. Any questions on this kind of thing?
Which is the other one that you figure out the end of it?
How do you mean? The 2 or no? How do you mean?
Like,
Figure out?
I know how to get the x plus 9 over 2, but what if like that's given and you have to find out the other piece of information? I don't know what we're doing.
I'm not exactly sure what you mean. If they tell you what the vertex is, and they, no.
I'll find it then.
Okay. Please. All right. So here, let me remind you guys about some things. You know this, of course, right? In the near future, we're going to talk about circles, and they have a certain form. If it's in this form, I know the center and the radius. So there seems to be this, don't worry, you don't have to know that yet. I just want to show you almost every standard kind of graph of a shape. The equation, if I put it in the right form, I see physical properties of the shape. So a circle, what's the most important things about a circle? The center and the radius. If I know those two things, I can make the circle, right? So those two things I can find directly from the equation if I put it in the right form. What about a line? I need a direction and a point to start at. All right, a direction and a point to start at. You guys kind of see what I'm saying? So it's really nice that the most important points of a shape, if I get the equation of the shape, put it in the right form, I can see those important points. I have to. If they're defining points, the equation is the definition of the points, there's got to be a connection. So with a parabola, here's what it's going to look like. Let me put it in function notation. Why not? Oh, shit. All right, so let's talk about this. That's what it's going to look like. Now let's analyze why this might be true. This one here does what we already know it does. What do you think is true if that's positive versus if that's negative? Yeah, if A is greater than 0, opens up. A less than 0, opens down. If A equals 0, it's not a parabola. So screw it. Let me stop there. We know that already. This HK is, for some reason, to be honest, I can't remember ever looking up why it's H and K. It's probably like Henry and Kim that came up with this a million years ago. They said, let's use our letters. But this is going to be the vertex. And let's see why that's true. So what I'm saying is, if I had a function like this, negative 2 times x minus 1 squared plus 3, it's going to open down. And what's the vertex? Now here's where you got to be careful. What's h? No. If h was negative 1 minus negative 1, there would be a plus here. So what is h? 1. So the vertex would be 1, 3. All right, so now for the next few minutes, I'm going to try to convince you that this is true. So for some reason, yes?
So we don't have to use the negative b over 2a to find the vertex?
Well, if here's the thing. If it's given to you in this form, I can just see it. What's going to suck for us, I don't know if you guys realize this, is putting it into this form if it isn't already. And what do you think it's going to involve? Putting it in this form is going to involve completing the square eventually, right? But before we do any of that shit, I want you guys to believe that this is what I just said is true. Don't just take it on my word. I could have just gone insane. You don't even know. So for some reason, the way I'm going to investigate this is to start with the square root. All right, so I'm going to build up to this. What's the square root look like? Well, what's the square root of 0? 0. What's the square root of 1? 1. Square root of 4? 2. So we should know that a square root looks like this. It's got that shape to it, right? Now, I've talked about what I'm about to talk about before, but I did it sort of quickly. Now I'm going to really stop and analyze it. What happens to the graph if I just alter the function just a little bit? Now can I start at 0? Why not? It gives me imaginary numbers, and I don't want to include those on my graph. I'm just going to do real numbers, right? So what's the lowest number I can start with? Which is really the domain of this, right? The domain is going to be that. So I can start at 2. When I throw a 2 in, what do I get? 0. So see how this moved over twice? My input had to be 2 bigger than before, because what's the first thing I do to the poor dude? Take 2 away from him, right? So it's sort of like, if the first thing to do is take $2 from you when you go in the bar, how you make sure you get in the bar? You better have at least $2 or you can't get in. So you have to have $2 more than you had to before to get in, because they're going to take $2 away. All right. And what's the next good point? So I moved over twice. Now watch. 1 used to go to 1, But how do I get a 1 output now? What do I have to put in to get a 1 output? 3. I got to put 2 more in. I used to have to put 1. Now I got to put 3. 3 goes to 1. It went 1, 2 over. That went 1, 2 over. That went 1, 2 over. Do you guys see what's happening here? So if I would have put a -3, how much would that shape? How much would it have shifted over? 3. That's crazy. Now, is everybody with me? The same exact thing. If I would have put a -7 in here, all my inputs would have been 7 bigger. It would have started at 7 and then went up from there. So what if this would have been an x plus 2? I go back to, right? Because now all my inputs can be 2 smaller than they used to be. So really what's happening is, if I start with this and I add and subtract something in here, add or subtract something in there, it's just going to move left and right. Because what variable is it that I'm affecting? The x. And what does x do? Left and right. Okay, I'll let that make sense. It doesn't even matter what function I'm talking about. If I'm talking about an absolute value function, we know that looks like this. Wee-haw. If I want to graph this instead, well, that's just going to move the whole thing over twice. 1, 2. So now it's going to look like that. That's freaking awesome as shit. Because now graphing stuff is a little bit easier. All I got to know is, like, what does it normally look like? And then just look, oh, okay, just move it over. Bam, there, I'm done. Next problem. So this idea is called translations. It's actually a subgroup of a bigger thing called transformations of graphs. All right, so like if I multiply by a negative, it would just flip the whole thing over. That would be a reflection transformation. This is what's called a translation. When you translate a graph, you just move it left to right, up or down. Do you guys get that? Is that decent? It's not too crazy of an idea. You can see why that is. And I love thinking about it like, if I subtract 2, then these have to be 2 bigger. That's why it goes that way. People always get tripped up. They're like, well, it was minus. Why'd you go that way? Because I got to overcome that minus. All my inputs have to be bigger than they used to be. So, looking again at the square root. What if instead of doing that, I did this? Let's do h. Now that is the graph up there, the black graph up there, right? So what am I going to do to every point on that graph? I'm going to take 1 away from the output, right? Okay, I like it. So it would just take that graph and move it down 1. Now I just want to make this, now watch this. What is this again? What did this used to be? Way back in the day. What used to be here? Y. If I move that over, it actually relates exactly the same way as the x minus 2 did. So when I had this, which way did that go? Up 2.
Right.
So if I move that over, see how that actually is with the y? That's with the y now. So that's going to control up and down. And all my outputs have to be 1 less than they used to be. Do you see that? That's why it does the same thing this does, because it's on the wrong side. And it does the opposite of what this looks like, because it's trying to overcome that. But if you move it with the variable, then actually you can look at it the exact same way. Oh shit, so tell me this. So if I had y equals the square root of x plus 3 plus 7, what are the shifts involved? It would move, back 3. Up 7 because it's on the wrong side. Do you see that? So whatever graph that was, it's going to add 7 to it. So that the outside does exactly what it looks like it's going to do, because if you put it with the letter, then it can interpret it the same way. Okay, I like it. What functions does this work with? Every function that ever existed and ever will exist. If you put wherever the x is, if you put x plus 3 instead, whatever the shape is, it's going to move back 3. That's insane. Absolute value, square root, cubes, squares. Squares. Oh shit, that's where we're talking. So now, look at this. What did I do to the x? In fact, x squared. Where is the vertex for just x squared? Where's the vertex for x squared? Just that the function was x squared. Where's the vertex? 0, 0, right? And then bam, 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 bam. Now watch. This would take the vertex and move it
To the right.
up 1. So from 0, 0, it's going to move up 1. And then it's going to move up 3, I should say to the right 3. I mean, right 1 and then up 3. So what's the vertex going to be now? 1, 3. Freaking 1, 3, right? I mean, that's why if it's in this form, I can just read off what the vertex is. Because it starts at 0, 0, I just got to see what translations were there to see where the vertex would have ended up. Okay, let me let all that sink in. You're going to do a lot more with translations and transformations in precalculus, because precalculus is graphing hell, right? They just show you everything about graphing so that when you get to calculus, that's not what's in your way. So now, if I give you something in that form, it's really, really easy to graph. So let's just start there, and then we'll see what if it's not in that form, and for some reason my teacher asked me to put it in that form. We're going to do some examples about how to put it into the right form. So what if I give it to you that form, like 3x minus 2 squared minus 1? So what can you tell me about this parabola?
Opens up.
Yeah, good. So it opens up. Yeah, what's the vertex going to be? 2, negative 1. Kick ass. Inside, change the sign. Outside, leave the sign alone. Now, one little thing about this. It's related to slope. Remember what I said. So if it's y equals x squared, it's like this basically. If there's a 3 there, it's going to go up faster. So it's very much related to slope. Because if I increase the slope, isn't it going to go up faster? Wow. So it's going to get skinny if this number is greater than 1. If this is a 1/3, it's going to go up slower. It's going to get fat. Right? So it's a little bit more about that A. Now here's the really hard question now. This used to be the easy question. What's the y-intercept? Shall I think I heard it, yeah. So you can't just say it's negative 1 now. Oh shit. Because when you make x 0, does this whole thing become 0? No. So when you make x 0, you get negative 2 squared is 4 times 3 is 12 minus 1. 11. Cool. So the y-intercept is 0, 11. What about the x-intercepts? This is a slightly easier thing now, because it's already done the work for you. So how do you find the x-intercept always? Set y equal to 0. So 0 equals 3 times x minus 2 squared minus 1. Isolate the thing that has your variable in it, right? So add 1, divide by 3. Take the square root, plus or minus. Add 2, so I get 2 plus or minus square root of 1/3, whatever the hell those are. You could do that in the calculator if you had to. Maybe. So if I want to find y-intercept, I make x 0. Sometimes that's easy. Sometimes you got to be careful. You just make x 0 and then see what happens. Don't make any assumptions. How do I find out the x-intercepts? I make y 0. All right, and then if I need it, and then I can graph it just like we did the earlier one, right? So, yes?
We're not going to have any x squared in the problem, right?
So we're gonna talk about what if there is an x squared. How do I put it in this form, right? That's what I said earlier. Don't get too excited. Yeah, exactly. I wasn't going to do that, but now I will because you said it. No, don't beat him up. He's fine. Let's see. What time is that? Let me do this one thing and we'll take a break. So if I give you something like, we're just going to do one quick example, take a break. I'll have a handout about this that has some problems for you to do. Let's do one. Yeah, let's start off nice. Oh, let's make it plus 2 just so it doesn't factor nice. So now this is what I was talking about earlier. Somebody said something earlier about why didn't you subtract it because you added or whatever. It's because I did it to both sides. Here I've got to do everything on one side. Technically I could subtract stuff from this and I just have to keep track of it, but it's sort of frowned upon. So normally what I would do is I would subtract 2 to make some room, but now I just sort of directly make some room. Right? So how do I figure out what goes here? Yeah, so half of negative 4. So it's the same steps. Half of negative 4, negative 2.
Squared.
And then squared 4. So I know I have to add 4. Now here's the thing. Here's the thing about the Indiana Jones thing. If you take something away, you better add something. Or if you add something, you better take something away. And if you don't do it correctly, boulder comes down, you die. Just trying to save your life. That's all I'm doing. So what did we just do to this side? We added 4. We changed the side. How do I not change the side at all at the same time subtract 4? Well, sort of, yeah. It's right here. I know how that's going to factor like what? I know now that's going to factor from this step. X minus 2 squared. And then 2 minus 4. That's crazy. So what's the vertex? Yeah, 2, negative 2. I like it. And of course, from the beginning, we knew it opened. What's the y-intercept? I don't want to use this. I want to use this. See, I've got the other form now. The y-intercept is easy now, like it was before. The y-intercept is 2. You could use this if you want to. It's the same thing, but it just looks worse. So y-intercept is 0, 2, and so forth. I mean, you can get x-intercept like we did just a minute ago. Do you guys see that a little bit? Not really at all? I suck? Okay, well. Yeah, I can deal with that. All right, let's take a break, and then we'll do some, hopefully you understand there's going to be a little more complicated problems than that. So be back here 12:35, is that all right? 12:40? Do you guys need a bigger break? Do you guys have an opinion either way? No? So be back at 12:38.